You hear the words energy, temperature, and heat all the time, right? But what do they actually scientifically mean? While the science behind them connects literally everything, from a monster hurricane to the chill you feel after a swim. And today, we're going to break it all down.
So let's kick things off with a little riddle. What could possibly connect a massive swirling hurricane, a simple hot mug of coffee, and your own body? The answer? The one thing that links them all is energy.
And energy is exactly where we have to start. Because before we can really get a grip on temperature and heat, we first have to understand the fundamental stuff they're made of.
At its very core, the definition is surprisingly simple. Energy is just the capacity to do work. And in the world of physics, work isn't about your job. It's just about making matter move. That's it. Whether it's gasoline making a car go or your own muscles lifting a heavy box, it's all just energy causing motion.
Now, energy basically comes in two main flavors. First up, you've got kinetic energy. Think of this as energy in action. It's the energy of motion, like a hammer swinging through the air or that powerful hurricane. It's doing work right now. Then you have its counterpart, potential energy. This is stored energy, energy that's just waiting to be used. Think of hailstones just hanging out in a cloud, or all the chemical energy that's locked inside gasoline. It has the potential to do work, it just hasn't been released yet.
But here's the thing. Kinetic energy isn't just for big stuff like hurricanes. It's happening on a microscopic level, all around you, all the time. Everything, the chair you're sitting on, the air you're breathing, is made of atoms and molecules that are constantly vibrating and jiggling around. And all that tiny motion means they have kinetic energy. So when you heat something up, all you're really doing is making those tiny particles vibrate even faster.
And that idea of all these vibrating atoms leads us perfectly into our next big concept. How in the world do we measure all that microscopic motion? Well, we actually have a name for it. We call it temperature. Now, the most important word on this slide is average. This is absolutely crucial. Temperature doesn't measure the total energy in something, it measures the average kinetic energy of all its little particles. So when you take your temperature, what you're really measuring is the average speed of all the jiggling atoms inside your body.
And understanding this whole average thing is key to solving a classic brain teaser. Imagine you have a small cup of boiling water and a huge bathtub that's just lukewarm. Which one of those actually has more total energy?
This comparison just lays it all out perfectly. Sure, the cup has a very high temperature. That means its water molecules are moving incredibly fast, on average. But the bathtub, even though its water is lukewarm, has so many more molecules in it. So when you add up all the energy from every single one of those slower moving molecules, the bathtub has way more total energy. Think of it this way. You could melt a lot more ice in that lukewarm tub than you could in that tiny, boiling cup.
Okay, so if temperature is the average energy, then what exactly is heat? This is where it gets really interesting, because heat isn't something an object has. It's something that moves.
Heat is really just energy in transit. It's the name we give to the transfer of energy that happens because there's a difference in temperature. So an object doesn't really contain heat, it contains thermal energy. Heat is just the term for that energy when it's flowing from one spot to another.
And it's got a one-way ticket. Heat always flows from a hotter region to a colder region. No exceptions. When you grab a hot mug, energy flows from the hot mug to your colder hand, and your hand feels warm. When you hold an ice cube, energy flows from your warmer hand into the colder ice, which is why your hand feels cold. That flow only stops when everything is the same temperature.
Now, for scientists like meteorologists, this whole idea of heat transfer gets broken down into two main types. The first one is sensible heat. It's pretty straightforward. It's the heat you can actually feel, the heat you can measure with a thermometer, like a warm gust of wind. But the other kind, latent heat, well, that's like a hidden superpower. It's the energy that gets soaked up or let go when something changes its state, like when liquid water turns into vapor.
And this hidden heat is so incredibly important and really deserves its own moment in the spotlight, because it plays a gigantic role not just in our daily lives, but in powering the weather systems for the entire planet.
I can guarantee you've experienced latent heat your whole life. You know that chilly feeling you get when you step out of a swimming pool, even on a blazing hot day? That's it. That's latent heat at work, because evaporation is a cooling process. So here's what's actually going on. For the water on your skin to turn into vapor, it needs energy. And it gets that energy by stealing it from your body in the form of heat. But here's the clever part. The water molecules that escape are the hottest ones, the most energetic ones. That means the molecules left behind on your skin have a lower average energy, and a lower average energy means a lower temperature. Your skin feels that drop, and you shiver.
Now, take that simple process of you getting chilly and scale it up to the entire globe. As water evaporates from the oceans, it soaks up unbelievable amounts of energy, latent heat. This hidden energy then travels up into the atmosphere along with the water vapor. Later on, when that vapor cools down and condenses in the clouds, all of that stored energy is released back out. This one single process is responsible for transporting more than half of all the energy from the Earth's surface into the atmosphere. It is literally the engine that drives our weather.
So, let's just quickly bring it all back together. Energy is simply the ability to make things move. Temperature isn't total energy, it's the average energy of an object's atoms. And heat? Heat isn't the thing at all. It's the process of energy flowing from a hotter place to a colder one. 3 simple but deeply connected ideas.
It just goes to show you that our world is absolutely buzzing with energy, in forms we can see and in forms that are completely hidden. We just saw how the hidden energy of evaporating water is powerful enough to drive our planet's entire weather system. It really makes you wonder, what other kinds of hidden energy are quietly shaping the world all around us, just waiting to be released?